Welcome to today's session. It's the advanced computer architecture class. It's a paper, regularly I'm saying it's a paper discussing the architecture of parallel computers, the hardware arrangements that exist within the parallel computers, the types of parallel computers, and the software performance within the parallel computers. Now we are in first unit. Now we are in first unit. Now we are in first unit. Okay. So under the first unit, up to that, we have seen Flyn's classifications of computers and the development layers. What are all the layered arrangement of a parallel computer by means of hardware and software? So these are all the points that we discussed. So in the last session, we have seen the Flyn's classification of computers and the development layers. Development layers in the sense the hardware and the software arrangement on a parallel computer. Okay. So far we have seen by means of instruction and data. So far we have seen the Michael Flyn classified the computers into 4 categories. The first among is, what is that? Single instruction stream over single data stream, SISD. So it is having single control unit and single processing unit with memory. Single instruction is processed over single data we have seen. So like that. Next we have seen the SAMD. So under SAMD there is a single control unit with a number of processing elements. Single instruction is operated over, you see, single instruction is operated over multiple data on each paralleling element. That means processing element. We have seen that. Under the SAMD, the parallelism is attained at data level as an important point we have seen. Then as a third architecture, we have seen MIMD. So what is that? Multiple instruction stream over multiple data stream. So under this architecture, multiple instructions are processed by processing units over the multiple data stream received from the shared memory. So I said, most of the parallel computers today are implementing this architecture. Here the parallelism is attained at instruction, and you see parallelism is attained at both instruction and data level. Okay. So the next thing is, what is it? MISD. I said about MISD. So what MISD is? Multiple instruction stream over single data stream. The another name is there for MISD. I said, what is it? Systolic array. Okay, vector computers are implementing MISD architecture. I said, okay, MISD. Under the MISD, parallelism is attained at instruction level. So these are all the points we have seen. Under Flyn's classification, then we discussed the development layers. Under the development layer, we have seen the arrangement, both software and hardware arrangement on a parallel computer is like this. The topmost layer is, what is that? Application layer. Next one is the programming environment. Then language supported, communication model, addressing space, hardware architecture. So under this, some components are machine dependent, I said. Importantly, hardware architecture and addressing space are machine dependent. That depends on the machine. The machine independent quantities are, what are all the, I said, applications and the programming environments. The language supported and the communication model, both that language supported and communication model, that two things are, you see, that two things are intermediate processes. Either they depend on machine or independent on machine. So they are placed, both language supported and the communication model are placed in between this machine independent and machine dependent. So these are all the points that we have seen so far. Okay. So before going to discuss, before we go further, we have to remember some points. That means what we have covered so far. Because we completed a major topic, Flyn's classifications of computer. Okay, so now I am listing out what are the points that we have seen so far in our last classes. First, we discussed the parallel computing model. So what a parallel computing model? I said it's a theoretical description. It's a theoretical description of computers, parallel computers, I said. So under that, we define what a parallelism is. So what a parallelism is? Doing more than one process at the same time. Then we have seen the generation of computers with respect to the hardware evolution. So there we discussed the generation of computers with the evolution of hardware. With the evolution of hardware. So what about the hardware components on first generation? What about the hardware component on second generation? So like the third generation. So during the generation process, the hardware is evolved, at the same time the performance is increased. So there I concluded with a concept that from the fifth generation of computers, the concept of parallelism was introduced. So now we are in the sixth generation, in the mid of sixth generation of computers, I saw. Okay. Then we completed a major topic. So what is the elements of modern computers? Then we had another topic. What is it? The evolution of computer architecture. So under that topic, we classified the computer architecture based on processing. That means started from scalar to parallel computers. So as I said just now, then we completed Flyn's classifications. So under the Flyn's classification, we classified the parallel computers, even in general computers, based on instruction and data stream. Okay. Along with that, we discussed what is that? Development layers. So these are all the portions, topics that we covered under the paper. What is that? Advanced computer architecture. Okay. So under this topic, we identified some important points. So after the completion of this topic that I listed out, we identified some important points. So what are all them? The first important point is this: attaining explicit, that means direct parallelism, is a complex process. We cannot achieve parallelism directly over a computer. We are using sequential computers. Using regularly, we are using sequential computers and laptops. Even we are doing the work. We are doing some works like documentation. Even we are running programs. Within a fraction of a second, the computer is producing the results. So what this one is, it's a sequential process. So what is that? It's a sequential process. Even the computer is producing the results more fast. It's a sequential process. Then you imagine about parallel process. Even we can say like this: under our computer, under our sequential computer, we can execute a single program at a time. Our sequential computer executes a single program at a time. Even the computer is executing a single program, it produces the result more fast. So with that concept, you imagine if a parallel computer is executing more than one program at the same time. The parallel computer is executing more than one program at the same time. So you have to consider this. So how it is? It's a massive parallelism. So even within a fraction of a second, a parallel computer executes thousands of programs. You just imagine. But in practical, attaining such explicit, that means direct parallelism, is a complex process. It's not a Easiest one, easy process. So we identified from the discussed topic, we identified the first point. What is that? Attaining of explicit parallelism is a complex process. Okay. Then we identified one more important point under the discussed topic. So what is that? Programming languages, that means software, that are yet to be developed. For our sequential computers, there are number of languages, softwares. Even per day, per month, even per year, languages are evolved. Even we know well, the advanced language today is .NET, Java. So like that, within the field of sequential computers, there are softwares to be evolved, to be developed. But in parallel computing process, there is a lack for software, programming language. So under the parallel computing environment, programming languages are to be developed. Still, it's a major need under the parallel computing process. So the second point we identified is, what is that? Programming languages are yet to be developed. More language development is needed under the parallel processing. We identified this. So within today, within parallel computing process, even within parallel computers, only implicit parallelism is possible. Implicit parallelism only exists through the conversion of sequential code into parallel code. You just imagine, suppose we are doing a program on sequential computer. So what we are doing? We are typing the program, sequential program, either in C, C++, or in Java language. So it's very easy for us. It's very easy for us. Just we are typing the program by using the editor, IDE, and we are running that, running the program, Java program, .NET program. So whatever the program is, whatever the language used for writing the program is. So that is sequential. So like that, there is no parallel execution of code. Our sequential computer, what I'm saying, our sequential computer executes sequential code one by one. Suppose we are running a C program, in the sense the computer executes the instruction one by one. You just imagine, in case of parallel computing, more than one program is to be executed, like the execution of a single instruction within a program. First program, second program. Even you can take like this. The sequential computer is executing first instruction, second instruction, third instruction, like that. Like that, a parallel computer has to execute first program, second program at the same time. So that is attaining of explicit parallelism. But today, implicit parallelism only exists. Even that implicit parallelism is attained with the conversion of sequential code into parallel code. Okay, so such a concept is needed. Even within today parallel computers, implicit parallelism is attained with the conversion of sequential code into parallel code. So what is the meaning, sir? Still, parallel computers are using sequential languages, sequential compilers. We discussed the compilers. Okay, pre-processors, pre-compilers, parallelizing compilers. We discussed that. So such compilers are used for converting a sequential code into parallel code. So still programmers are developing sequential code, even sequential programming. Even programmers are using sequential languages for programming parallel computers. We can conclude like that. Programmers are using sequential languages, sequential programming languages. For what purpose? To program for parallel computers. Okay, so such a concept is still exists. So what is needed here? What is needed? A direct parallelism is attained by writing parallel code by using a parallel programming language. A direct parallelism is attained by writing parallel code by using a parallel programming language. So that one is impossible today. It's very difficult to achieve. Okay. So what is the conclusion of this? No direct parallel programming available. So here, these are all the points to be identified after discussing the topics. So you think about these points. You think about these points. You think about the listed points. All the points are related to software. You see, from the first point, that means from attaining explicit direct parallelism is a complex process. So from that points to the no direct parallel programming available, the last one, all the problems to be listed, identified are based on software. So what is the meaning of this? There is no major problem at all in the field of where hardware side under parallel computing process. So within the field of parallel processing, there is no major problem in hardware side. Hardware devices are fabricated to attain parallelism, but it is very difficult to achieve parallelism by using software. So it's the main conclusion that we have to make after discussing these points. Okay, so with this idea, next we have to move for an important topic. What is that? System, you see, system attributes to performance. So it's our next topic. So what about these topics, sir? System attributes to performance. So what it discusses? So under this is a new topic. You see, it's a new topic I'm saying. So under this system attributes to performance, what we are going to discuss? Here we are going to discuss some factors, measurements, benchmark units used for evaluating the performance of a parallel computer. You follow what I'm saying? Under this topic, under the system attributes to performance topic, we are going to discuss the performance measures, factors that are used for assessing, measuring the quality of parallel computers. Okay. So under this topic, first we have to consider the ideal performance of a computer. Ideal performance means what? The maximum performance, the expected performance. Okay, so what about the facts are? The ideal performance, the expected performance, maximal performance of a computer in general, or the ideal performance of a parallel computer needs a perfect match in between the machine capability, that means hardware, and the program behavior, that means software. So what is the meaning of this? Suppose a computer is there, whether it is parallel computer or a sequential computer. Even you take like this, there are two computers. There are two parallel computers. We take our topic. There are two parallel computers before you. You have to say which computer is doing the work more fast. You have to say which computer is performing well. So in order to measure the performance of a parallel computer, the first thing, the needed thing is what is that? The ideal performance, the maximal performance of that computer. So as an example, I said to you, you have to assess the performance of the parallel computers, two parallel computers sit before you by using just a minute. So you have to assess the performance of the parallel computers before you by considering okay, you have to assess the performance of a parallel computer by considering, by considering the match, the cooperation, the cooperation in between the hardware and the software. How your parallel computer hardware is doing the work, how the software on that parallel computer is executing. So how it is cooperate with each other, how the hardware components are cooperating with the software, and how the software environment is cooperating with the hardware devices. So you have to do the comparative process. So what I'm saying, you follow ideal performance in the sense I'm explaining. Once again, I'm saying, the ideal performance of a computer is a perfect match in between the machine capability and program behavior, I'm saying. So what is the meaning of this? Just a minute, students. One third final year student is entered, I think. For the student, I'm saying a message. Nadira Safin, it's a MSc class. Okay, so now I am engaging MSc class. Next hour is allotted for you, so you just please log out from this session. Nadira Safin, please log out from this session. It's a MSc session. In the next session, I will come for you. Nadira Safin, இது வந்து MSc கிளாஸ் எடுத்துட்டு இருக்கேன். இது வந்து BSc கிளாஸ் இல்ல. அடுத்த அவர் வர நீங்க லாக் அவுட் ஆயிக்கோங்க. ஓகே. So it's the ideal performance of a computer that needs a perfect match between which one? Machine capability and program behavior, I said. So what is the meaning, I said? Suppose there is a parallel computer. Under the parallel computer, the performance of the parallel computer is assessed by measuring the cooperation in between the software and the hardware components on the computer. Okay, so it's the ideal performance. It's the comparative process of software, how a software is cooperating with the hardware component and how the hardware components are responding with the software needs. So you have to do this. Whether they are working correctly, whether they are matching correctly, whether they are doing the work perfectly. So this one is, what is that? Ideal performance. So the ideal performance of a computer needs a perfect match in between the machine capability and the programming behavior, that means software. Okay, so next point we have to discuss is, so that's why I'm saying machine capability. So what is machine capability? Machine capability can be enhanced with the needed hardware technology. Suppose there is a computer. So once again, I'm taking the same example. We have to compare the performance of two parallel computers. Okay, so you have to compare. You have to say, you have to assess which machine is doing the work more fast. So in order to find out, you have to consider the machine capability. So what is machine capability and how it is to be enhanced? So the machine capability is enhanced with the hardware technology, the required hardware technology, needed hardware technology, and the architectural features. Architectural features in the sense how the components within that computer are arranged, how the memory is arranged, where the processor is placed, where the processing elements are arranged, where the control unit is there. So these are all the architectural features. and the efficient resource management. Whether memory is responding in time, whether processing elements are doing the works in correct timing, whether the control unit is sending the signals, controlling signals in time. So these are all the factors to be assessed, to be considered, even importantly, enhanced to improve the machine capability. Okay, but so it's a positive side also in the field of hardware side, it's a positive side. So already I told you there is no problem at all, maximum problem at all in the field of hardware. But in the field of software, it's a very complex process. It's a difficult case in the within the field of parallel computers. Okay, so under the software, the first thing is what is that? Program behavior is very difficult to predict. Okay, once again I'm coming for the same example. You compared the two parallel computers by considering the machine capability. Sir, this parallel computer is having more hardware performance. The processors are fastest processors, you are saying. The architectural features, arrangements are like this. This computer, the first parallel computer, is having more memory than the second parallel computer. So the first parallel computer is doing the work more fast. So by considering the hardware terminology, machine capability, you are determining a result. This machine is doing more fast. Okay, so you concluded with the machine capability that means from the hardware side, with the help of hardware, you easily predicted the performance of a parallel computer, but it is very difficult. But it is very difficult when you are assessing the performance of a parallel computer from the software point of view, from the programming behavior point of view. So what about that? Programming behavior is very difficult to predict. And the programming behavior is also depending on the application and the runtime environment. Suppose your program is running on a parallel computer. Okay, the program is running on a parallel computer, and that running process depends on the runtime environment. Suppose a program is running on two parallel computers, that be two, and the two programs are expecting inputs from the users. On one computer, one parallel computer, user has given the input. The process will begin. Okay, there is no problem at all. So on the another computer, no input is given by the user. Still the program is waiting for the input. Okay, so the program which accepted the input completed more fast than the program that waits for the input. So under that aspect, you cannot say the first computer is doing the work more fast than the second one. Even the second parallel computer is having more hardware features than the first one. So it's very difficult for us to assess the performance of a parallel computer or computer in general by considering the software. So what are all the remaining factors that are affecting the programming behaviors? So these are all the important points that are affecting the programming behaviors of computers, whether they are sequential or parallel. Algorithms, the selected algorithms for doing the program, process, the data structures used for arranging the data, programming skills, the programming skills of a programmer, and the language efficiency, the features that are available within the selected language. So these are all the some factors affecting the programming behavior as a overall the software side. So under the new topic, system attributes to performance, we identify two important points. So what about that? The ideal performance, once again I'm saying, the ideal performance, the maximal performance of a computer, the maximal performance of a computer needs a perfect match in between the machine capability and program behavior. Okay, so what is the meaning? I said both software and hardware must cooperate with each other on a parallel computer in order to do a work. Both must respond in time. So that is the ideal performance, maximal performance of a computer. So it's very easy. Even there is no problem at all in the field of hardware. So the machine capability is to be determined by means of hardware technology and the architectural features and efficient resource management, efficient management of resources. But in case of software side, that means under the programming behavior, there are problems. We cannot predict the performance of a parallel computer by means of program behaviors. That means by means of software very easily. Okay, definitely the programming behavior is depending on the runtime, the running time of that program, because the runtime involves several factors. I said one among them is, I said, what is it? The awaiting time of inputs. As an example, I said. Then I listed out the factors within the programming behavior, the factors that affects the programming concept. That means the entire software is, what is that? Algorithms, data structures, programming skills, and language efficiency. Importantly, the last point is this. Even a parallel computer is taking a program. Even a computer is taking a program. For the collected program, a parallel machine, a parallel computer produces the results within a fraction of seconds. Okay, so it takes, after the completion of that program, that same program, actually the same computer may take another program. For the secondly selected program, it may take timing. You see what he said? For the first program, for the first selected program, a parallel computer results within a fraction of a second. But for the second program, you see, for the second program, the same parallel computer will produce a result for a longer time by taking longer time. So we cannot say a parallel computer or in general a computer produces results within this timing. For example, within 2 milliseconds, 2 microseconds, 5 nanoseconds for all processes. So the expected output, the output timing of a parallel computer heavily depend on process. That means program to program. The machine performance is heavily depend on programming process. So that's why I said the last point, machine performance varies from program to program. So what we have to conclude? By considering the software, the peak performance, that means maximal performance of a machine is parallel computer is difficult. Okay, with the even for the real world application. The next thing, machines cannot have average performance also. Machines are not having average performance also. Performance measure, you see the performance measure. So from these all points that we discussed under the system attributes to performance, we have to conclude this: performance measure is not a single quantity. In order to assess the performance of a parallel computer or a computer, it is not a single quantity. Performance measure is not a single quantity. It involves all the benchmarking measures units like algorithms, data structures, resources selected, resources utilized, like this. Okay, mainly the benchmarking, the performance measures, fundamental factors that affecting even projecting the outperformance of a computer are turnaround time, clock rate and CPI, and the MIPS rate, millions of instructions per second rate. So these are all the some fewer factors. So like that, under this topic, in the forthcoming sessions, under this topic, we are going to discuss such factors. So in the next session, first we have to select what is turnaround time is and what a clock rate is next and what CPI is. So we'll see these things, the fundamental factors in detail on next session. Okay. Thank you, Ananda.